Good morning, students. Today we are going to read the fourth lecture in the topic of current electricity, subject physics, O levels. So concentrate yourself, a lot of concepts will be involved. So we are going to start now. Resistance. All metals have some resistance. In an electric circuit, resistance reduces the size of the current. So, the function of the resistance is to reduce the size of the current in an electric circuit. A resistor is a conductor with known value of the resistance. So, this is another point to remember. A resistor is a conductor with known value of the resistance. It can be used to control, can only reduce the size of the current flowing in a circuit. Resistance, therefore, is a measure of how difficult it is for the current to pass through the circuit. So, this is the resistance. This is actually the measure of how difficult it is for the current to pass through a circuit. Resistance of the conductor is defined as the ratio of the potential difference across the conductor and the current flowing in it. Here is the equation. R is equal to VI. So from the equation we can see it is the ratio of the potential difference across the conductor and the current flowing in it. The SI unit for the resistance is the ohm. 1 ohm is the resistance of the conductor. So again, from the equation we can write the definition of the ohm. So 1 ohm is the resistance of the conductor through which a current of 1 ampere flows when a potential difference of 1 volt is maintained. For the definition, R is equal to VI. So R's unit is ohm. So 1 ohm. Volt, potential difference is having the unit volt. So 1 volt. And current is having a unit 1 ampere. So 1 ohm is equal to 1 volt over 1 ampere. The material through which a current flows offers some resistance to the moving electrons. A material with a high resistance only allows a small current to pass through it when a certain voltage is applied, whereas the material with a low resistance allows a larger current to pass through it for the same applied voltage. The wires connecting the components in a circuit have a low resistance, while the wires in the filaments of the lamps have a high resistance. So this is very important point which normally comes in the paper number 1 MCQs of the physics. So the wires connecting the components in a circuit have a low resistance, while the wires in the filaments of the lamps have a high resistance. That's why the lamps glow, because of having the wires with high resistance. When the lamps are connected in series, their resistance combine in the same way as the voltages of the cells in the series, they add. So when the lamps are connected in series, they are having high resistance. They therefore offer a greater resistance to the current than each lamp would separately. The next thing that we are going to read is the lamps and the current size. The size of the current flowing through a circuit can be estimated by looking at the brightness of the lamps in this circuit. So this is very important point to remember. The size of the current flowing through a circuit can be estimated by looking at the brightness of the lamps in this circuit. So more the current flows, more will be the brightness. Less the current flows, less will be the brightness. A lamp shines with normal brightness when it is connected to one cell as shown in figure A, the lamp shines more brightly than normal when it is in the circuit when two cells, figure B, and shines less brightly when it is in the circuit with one cell and another lamp as shown in figure C. So here are three figures. So normal brightness with one cell, the more brightness with two cell, and the brightness lesser than the normal with one cell and with an other lamp. Here is an exam tip for you people. If there is 1 ohm of the resistance, there is 1 ampere current and 1 voltage of the potential difference. If there is 2 ohm of the resistance, there is 1 ampere of the current but 2 voltage of the potential difference, and so on. Okay, the next thing that we are going to read is the resistors. Any conductor that is used to provide a known value of the resistance in a circuit is called a resistor. The primary purpose of the resistors is to control the size of the current flowing in a circuit. And there are two categories of the resistors. One is fixed resistor, second is variable resistors. The name to variable resistor is also a rheostat. Okay, now we are going to read what is fixed resistors. Fixed resistors have fixed values of the resistance. As such, there is limited control because the resistors having fixed values of the resistance, that's why limited control is there. The common types of the fixed resistors are, that is resistors with fixed values of the resistance include, so these are some common types: carbon film resistor, carbon composition resistor, tin oxide resistors, and the wire wound resistors. Some fixed resistors are shown below. So here are some fixed resistors, and this is the symbol used for fixed resistors. Whereas the rheostat, that is variable resistor, is commonly used in the circuit to vary the current of the electric current. As shown in the figure, this sliding contact when moves will vary the length of the resistance wire in the circuit, and hence the resistance will be changed. So here is the sliding contact. When it moves, will vary the length of the resistance wire. So here is the resistance wire. So because of its movement, the resistance wire's length will be changed, and hence the resistance will be changed. And here is the symbol of the variable resistors. Each and everything is very important. Some questions comes in the paper number 1, some in paper number 2, and some will be come in paper number 4. So now we are actually, more of the material is about paper number 1 and paper number 2 of your physics paper O levels. This question normally comes in paper number 1. Okay, the next thing that we are going to read is the light dependent resistor. In short, it is called LDR. A light dependent resistor, LDR, is made from two pieces of the metal which are joined together by a semiconductor. A semiconductor is a material that has just a few electrons which can move freely. When the LDR receives light energy, more electrons are released in the semiconductor to move freely through it, and the resistance of the LDR becomes lower. When the amount of the light shining on it is reduced, fewer electrons can flow and resistance will rise. So, light shining on it is reduced, resistance will rise. Light shining on it will increase, resistance will be lower. And here are LDR. These are two metals joining with semiconductors. And here is the symbol of the LDR. The next thing that we are going to read is the determining the resistance of a resistor. A rheostat is needed to find the resistance of an unknown resistor. The voltmeter is connected in parallel as shown. So here is unknown resistance, and we will connect a voltmeter in parallel with the resistance. Use the rheostat to adjust the size of the current to a convenient value. Hence, record the reading shown on the ammeter current I and voltmeter potential difference V. So, by adjusting the some known value of the current in the rheostat, we will note the current I in the ammeter and the volt in the potential difference in the voltmeter. Adjust the rheostat to take 5 sets of the readings of the I and V. Calculate the resistance from the equation, and then we will put the values into the equation. R is equal to VI. So V will be known, I will be known. So we will put these values into the V and I to get the resistance. The next thing that we are going to read in the lecture is factors affecting resistance of wire. So the first factor that we are going to read that affect the resistance of the wire is the length. For a wire of uniform cross-sectional area A, the resistance R is directly proportional to the length L of the wire. So it is given, it is conditional that cross-sectional area should be uniform of both the wires. Then resistance of the wire will be proportional to the length of the wire. That is, R is directly proportional to L. So longer the wire, the higher the resistance. So this wire will have larger resistance as compared to this wire. So longer wire have higher resistance than shorter wires. The next factor that we are going to read is the cross-sectional area. So for a wire of fixed length, so now length should be fixed. The resistance is inversely proportional to the cross-sectional area A. That is, R is inversely proportional to A. So the thinner the wire, the higher the resistance. So because R is inversely proportional to A, so this is a thinner wire that will have more resistance as compared to thick wire. So thinner the wire has a higher resistance than thicker wire. So this wire will have more resistance as compared to this wire. The next thing that we are going to read as a factor that affect the resistance is the material. So material also depends. So resistance also depends on the material. Resistance depends on the kind of the substance. Copper is a good conductor and is used for connecting wires because this is having less resistance. So that's why it is used for connecting wires. Whereas the nichrome has higher resistance and is used in heating elements of electric heater. The next factor that we are going to read is the temperature. The resistance of a wire also changes as the temperature changes. For metallic wires, that is tungsten or copper, as temperature rises, the resistance also increased. But for some materials like silicon and germanium, as temperature increases, the resistance decreases. Alloys such as manganese and constantan are practically unaffected by the temperature change. Resistance coils are made of these materials as their resistance should keep constant as their temperature rises. So this is very important to understand and note that resistant coils are made of these materials. So alloys such as manganese and constantan form normally resistance coils. Okay, the next thing that we are going to read is the resistivity. The resistivity of a material is numerically equal to the resistance of 1 meter length of it of cross-sectional area 1 meter square. And here is the formula. Capital R is equal to resistivity L over A, where this symbol is resistivity, L is the length, and A is the cross-sectional area. The SI unit for the resistivity is ohm meter. Note, the lower the resistivity of a material, the better it is conductor of electricity. Low resistivity metals such as copper are used in wires, whereas the high resistivity metals such as nichrome are used in heating coils of electric kettles or electric heaters. Here is a question that will make your concepts about this topic more clear. This kind of questions come in paper number 2. In an electric fire, 15 meter of nichrome wire of resistivity this, so this is the length, this is the resistivity, is used as a heating element. A part, calculate the resistance of the nichrome wire given that its cross-sectional area is this one. So this is A. So formula used will be R is equal to resistivity L over A. So resistivity is here, 100 multiplied by 10 raised to the power minus 8. Length is here, that is 15 meter. And cross-sectional area is here, that is 2 multiplied by 10 raised to the power minus 7. Solve it on the calculator. You will get the answer 75 because this is resistance. So unit will be ohm. The next part is, if the nichrome wire is replaced by copper wire of resistivity 1.7 multiplied by 10 raised to the power minus 8 ohm meter and of identical length and cross-sectional area, calculate the resistance of this copper wire and comment on its value with respect to that in A part. Okay, first we will find the resistance. So here is the resistivity. Rest of the values will be same. Length and cross-sectional area is same. So look now. Formula will be used. R is equal to resistivity L over A. Now the resistivity given is 1.7 into 10 raised to the power minus 8. Length is same, that is 15, and cross-sectional area is also same. So solving it on the calculator, you will get the answer, that is 1.3 ohm. So look at the A part and B part. In A part, nichrome wire was used, whereas in B part, copper wire was used. So it is very clear from the answers that copper is having very low resistance as compared to nichrome wire. So because the wire is to be used in electric fire, so copper is unsuitable because it is having less resistance. Nichrome is very much suitable for making electric fire because it is having very greater resistance as compared to copper. So look now, here is the comment. The copper wire is not suitable as the heating element due to its very low resistance of 1.3 ohm. The nichrome wire is more suitable as it has a much higher resistance of 75 ohm. The next thing that we are going to read in the lecture is Ohm's law. Ohm's law states that the current flowing in a metallic conductor is directly proportional to the potential difference applied across its ends, provided the physical conditions such as temperature are constant. So if the physical conditions are constant, then current will be directly proportional to the potential difference. So I is directly proportional to potential difference. The current voltage characteristics for various conductors. So I over V characteristics for various conductors. The following graph shows the typical characteristics of various conductors. Pure metals at constant temperature, resistance remains constant as potential difference increases. So in these kind of the pure metals, resistance remains constant as potential difference increases. So look now, potential difference is increasing, but resistance remains constant. The ratio of V over I remains constant provided physical conditions such as temperature remains constant. Next thing that we are going to read is semiconductor p-n junction diodes. Resistance decreases suddenly at around 0.6 volts. So you can see here the resistance suddenly decrease. So this is the figure which is showing the effect. The next thing that we are going to read is the filament lamp. Resistance increases as potential difference is increased. So look now, as the potential difference increases, the potential difference resistance also increases. The next thing that we are going to read is the thermistors. Resistance decreases as the potential difference increase. So as the potential difference increase, the resistance decreases. All conductors which obey Ohm's law are described as ohmic conductors. So now we are going to read another important topic in the lecture, that is non-ohmic conductors. Materials which do not obey Ohm's law include ionic solutions, gases and superconductors, and thermionic devices. Even if the temperature is kept constant, such materials are called non-ohmic conductors. So you have to remember some examples of the non-ohmic conductors, because this question frequently come in the paper of 1 or 2 marks. A part is made in a long question. So here are the materials like ionic solutions, gases, superconductors, and thermionic devices are the examples of the non-ohmic conductors. Not all substances and objects give a straight line for the current voltage graph. If you investigate how the current I varies with the voltage V in a filament lamp, a light bulb, you can see that the graph is a curve like this. You will see here. As the current flows through the metal filament, it gets hotter, so its resistance increases. So resistance increases, so that's why less current will be passed. This means that graph gets flatter as shown below. So more the voltage, resistance will be increased, so less current will be passed through it. So that's why the graph gets flatter. Another example of the non-ohmic resistor is thermistor. It is useful in electronics and is made of the semiconductors. As more current flows through the thermistor, it gets hotter and its resistance decreases. So because the resistance is decreased, that's why more current will pass through it. The graph gets steeper. Take note, the definition of the resistance R is equal to VI applies to all conductors. For non-ohmic conductors, the value of the R is found by taking the gradient of the tangent at a point on the VI graph. So this will be the method to find the value of the R, by taking the gradient of the tangent at a point on the VI graph. Here are some key terms which you have to know, understand and learn. So look now. Resistance is the ratio of the potential difference across a resistor to the current flowing through it and is measured in ohms. Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference applied across it, provided the physical conditions remain constant. The resistance of a metallic conductor can be determined using an ammeter and a voltmeter. Physical conditions such as the temperature of a metallic conductor affects its resistance. The IV characteristics of non-ohmic conductors are generally nonlinear, that is, they do not obey Ohm's law. So this was the lecture, students. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.